Now we want to be able to generate the arcsine and the arccosine functions, and we can generate these from the arctan function. Now if we consider this simple diagram here, we have a right angled triangle with the angle theta. If this length is 1 and this length is x, then this must be the root of 1 minus x squared. And we can see that if we were to apply Pythagoras to both the x value and the root of 1 minus x squared. So if we square this, we're going to end up with the value of x squared. And if we square this, we're going to end up with a value of plus 1 minus x squared. So this cancels out with this, and it just gives us the value of 1, which is what we expected. So using this simple identity, we can then go ahead and we can generate the arcsine and the arccosine functions from our arctan functions. So let's see that on the next page. Now the sine function is given by the opposite over the hypotenuse. But in the previous diagram, the hypotenuse is a length of 1. So we're going to have opposite over the value of 1, which is just simply the opposite. So the sine of the angle theta is nothing other than the length x. So if we had the triangle and we had the opposite, which is just the length x, and we had the hypotenuse, then the sine of this angle is the opposite over hypotenuse, which is just going to be equal to the length x upon the length 1, which is just the value of x. So it means then, in order to find the theta, what we do is use the arcsine of x. So we can say theta is arcsine of the length x. But we can write tan theta as the opposite over adjacent. And from our diagram, the opposite is x and the adjacent is the root of 1 minus x squared. So from these two bits of information, we can therefore say that angle theta is going to be the arctan of x upon the root of 1 minus x squared. And this is the identity here that we're going to use in order to generate the arcsine function from the arctan function. We can use a similar argument in order to work out the arccos function. We know that the cosine of a function is the adjacent divided by the hypotenuse, but the hypotenuse is a length 1, therefore the cosine is just going to be the adjacent divided by 1, which is just the length of the adjacent. But the length of the adjacent in this case here is the root of 1 minus x squared. So we would have our triangle and our angle here that we're interested in. We would have the x here, we would have the root of 1 minus x squared. The cosine is the adjacent, which is this side here, adjacent, divided by the hypotenuse. But the hypotenuse is just equal to 1. So it means that the cosine is going to be this root of 1 minus x squared divided by 1, which is just equal to the root of 1 minus x squared. Now, as we've seen previously, the tan of an angle is the opposite over the adjacent, which is the root of 1 minus x squared all upon x. So therefore we can work out theta from the arctan of the root of 1 minus x squared all upon x. Therefore from this and what we've seen here, we can see that arccos can be written as the arctan of the root of 1 minus x squared all upon x. So we're going to use this identity here in order to generate the arc cosine function from the arc tan function. So let's start off by looking at the arc sine function. If we drop into the terminal, run task, edit microcode, then this will bring up the command line interpreter. And from the command line interpreter, we will be able to see all of the individual micro instructions. So I've already generated these. So we'll type in micro steps, and we're interested in the CORDIC arc sine function, and it's going to be addressing mode 0. So here are all of the micro instructions that are required in order for us to run through this full instruction. And you can see it's a good bit bigger than most of the rest of the ones we have looked at so far. So we can see we've got, including 0, we've got 33 individual micro instructions. Now the reason that this is so large is because we're having to generate, in effect, this equation here, x upon the root of 1 minus x squared. So we're having to bring in a value of x. Now x is nothing other than a value that will be converted back to an angle, but we have to bring this value in, and we have to, first of all, we'd have to bring it in and square it. Then we would have to subtract it from a value of 1. Then we would have to find the square root, and then we would have to do the division here as well. But we can do all of these things within this microcode. We've got access to a floating point multiplier, so we can multiply the input twice, and we can subtract it from a value of 1. Now the only thing that's awkward about this thing here is actually getting access to the number 1. But we're able to get the access to the number 1 if we have a look at the actual floating point unit. So we head into the floating point unit and we get to this point here. So 3C00 is the number 1. So I can get access to this number 1 by ensuring that we choose this number here. So C arctan is going to be the number 10. If I choose number 11, now I choose number 11 by making the ALU 0, 1, 2 and 3. So I choose the correct values to give us number 11. So I can get access to this number here via that route. Now I'm not going to talk through all of the code here, but each of these lines where we can see our ALU3, ALU1, ALU0, and also this line here, just the ALU0, and this one and this one, all of these, all they're going to do is they're going to generate the square, they're going to generate the 1 minus and the square root and also the division. So we're shuffling all of the values round about our CPU so that we can synthesize this little bit of algebra. And then this value here becomes the input to our CORDIC unit, which will then generate the arctan. So when it's generated the arctan on this here, the answer will actually be the arc sine. So let's see what the arc sine actually looks like. We'll pick a value and we'll test it out with one of the values. So let's have a look at the arc sine function, and we can see here that the domain is actually already restricted from -1, which gives us minus pi by 2, to plus 1, which gives us pi by 2. So we don't need to do any folding or restricting of the domain as we had to do with the sine, the cosine and the tan functions. So what we can do is pick out a value here that we can use to test. So if we get the value 0.5, so 0.5 should give us pi by 6. So we will use this as an example. So we're going to use the number 0.5 as an input, and in our 16-bit float that is the number 0 cross 3800. Now we're expecting to get pi by 6 as an output, so if we say pi divided by 6, so we expect this 0.52359. So if we put in 0.52359, then we expect our output to be somewhere around about 0 cross 3830. So let's write our little piece of test code. We've got new file, we can call it CORDIC underscore arc sine underscore test.asm. We're going to have our dot code, which is 0 cross 8000. We'll have an end command, and we'll have the actual instruction. So it's going to be our arc sine, so it will be CORDIC arc sine, and the input will be the number 0.5. Okay, so the assembler will automatically convert this to the number 0 cross 3800 for us, and we'll put the answer, let's say we put the answer into R3, and we terminal, run task, assemble file, and you see it's assembled successfully. So let's load our program up. Edit contents, open, and it's CORDIC asine test.mc. That's it loaded in, and now we can actually run through the simulation. Now we should get our answer in register R3, and you can see it counting up now. This is the CORDIC unit counting up, and these are all the instructions. That's it finished, and it's given us the answer 3834. So we'll stop the simulation. Now what we were expecting to get was 3830. So we're only in effect 4 out in terms of our floating point numbers. So let's see how close we actually got. If we head in to look at our calculator, so we got 0 cross 3834, and that is 0.5254. Now we were expecting this number here, 3830, which would have been 0.5234. So we are still correct to 2 decimal places. In fact, we can check and see the actual percentage error. So we put in 0.5234 divided by 0.5254 multiplied by 100, and you can see we're correct to 99.62%. So the last thing we want to do is actually get a graphical plot of our arc sine function, so we can check and see that all the rest of the values look okay. Now what we can do is instead of running it on the machine here, again we can run it on our emulator. So let's go ahead and do that now. So I already have this piece of code here, CORDIC_AS_AC, and I believe this is another one of Timothy's pieces of code. Now what we're going to do is we'll just adjust it, because this plots out the arc sine and the arc cosine. So I have commented out the arc cosine, so it should just plot out the arc sine. So we'll go in here and we'll go run task, and we'll assemble the file. So that's the file assembled, and then we can get in to terminal, run task, and we will emulate. Takes a few seconds for the emulator to run up, and we can press R for run, and then we can do the graphics dump. So we'll go GD for graphics dump, and that's a dump to graphics. Now we can get in here and reset this, and then we can load up our new program. So we're going to have our splash screen going in here, so we'll go open and we'll find the splash. Okay, and then we'll go into the graphics 2 and we will load in our graphics.data. Okay, so that's it here, graphics.dat. Open it up and we can check and see that there are actually values. Okay, so you can see there is actually values here, so it should plot something off. And we'll go simulate, tick enabled. So this is us starting to run through all of the .d data folder here, and it should start appearing here. So what I'll do is I will stop talking and I will fast forward this, and I'll get you at the end of the simulation. So this is the end of the simulation, and we've got our function here, which is our arc sine. So if we compare this to what we have on our graphical calculator, the graphical calculator looks like this. So in effect, we've got this little section here. Okay, so you can see it is heading in the right direction. It heads like this and then up like this. So let's have a little look at it again. So it is heading in the right directions. So that's us done our arc sine function. We can go ahead in the next video and we will do our arc cosine function. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.